Now the last little thing I want to go over here is what is our stoichiometry, because any math that we do can always turn back into stoichiometry some way. And yes, I hear the groaning from here. Now, all this gives us is it gives us another way to convert with moles, right? So we had a bunch of different, that's not what I wanted. We had a bunch of different mole conversions that we had, right? So we had our little diagram where we had moles and we converted it to volume at STP. We converted it into grams. We converted it into molecules, right? All this is a fourth one. So now we have not at STP, right? So this is just the fourth way to convert between moles that we can use for our equation. But aside from that, the process doesn't change. It's always the same three steps. Convert what you're given into moles using one of these four, multiply by the mole ratio from the equation, and then convert out into whatever the question's asking you based on whichever one you need. Right, so same three steps as always. I'm just giving you another option. So let's try one of these. So there's a lot of text here, but it's basically we are reacting 9.8 grams of magnesium, and I want to know how much hydrogen is going to be produced, and I gave you the conditions for the hydrogen. Right, so actually we'll go through this one together, kind of give you a little bit of a idea how we're going to do this. So first thing we need to do is we need to see what we're given, right? So we're given a bunch of numbers here. How can we find moles? Well, again, we know that moles is equal to grams over molar mass. We know that moles is equal to volume at STP over 22.4. We know that moles is molecules over Avogadro's number. And now we know that moles is equal to PV over RT. So which one can we solve for? Well, here I have atmospheres and Celsius, so atmospheres and temperature, which gives me pressure and temperature. R is a constant, but I don't know V. So I can't solve for moles using this one. I wasn't given molecules. My gas isn't at standard temperature and pressure, so I can't use this one. So let's see if we can use our grams here. And just so happens, 9.8 grams of magnesium. So we can turn that into moles because we know that. So our first step is we have 9.8 grams of Mg. We want to turn that into moles, so 1 mole for magnesium is 24.3 grams. And that gives us 0.403 moles of Mg. Right, so that's our first step, convert to moles. Second step is mole ratio. Here we want to go from magnesium to hydrogen. So we're going to take the number we started with, so 0.403 moles of Mg. Our mole ratio, I want to be in hydrogen, so that goes in the numerator. I'm coming from magnesium. The ratio in this case is 1 over 1. Right, because our coefficients here are 1 and 1. They're not written, so we just assume them. So we have 0.403 moles of H2. Our third step is to convert from moles to whatever we're being asked for. We're being asked for volume, right? So if we're being asked for volume, I'm going to have 3 of the 4. So I have volume, I'm solving for volume. I have pressure, I have temperature, I have moles. R is a constant, right? So here, PV equals nRT. We're solving for V, so V equals nRT over P. N is 0.403. R, 0.0821. temperature. Temperature is 15 degrees Celsius. So 273 plus 15 gives me 288 Kelvin. Divide that by the pressure, which is 1.3 atmospheres. And I wind up with a final answer of 7.34. And since we're in volume for the ideal gas law is going to be in liters, so liters of hydrogen. Right, so that's the stoichiometry problem. Same 3 steps. It's just that now you can use the ideal gas law for one of your conversions. All right, so that is it for the notes on this. And I will see you guys at some point later.